Right, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2015. We're going to look at question 7 here, and this is quite a long question. It's 50 marks. So it's about a plane that is flying horizontally at point P, and it's flying at a height of 150 meters. So they've changed it to kilometers here, 0.15 kilometers above level ground, which it begins when it begins its descent. So it descends down to O here, and it touches down here. Now, taking O as the origin, so if O is the origin here, this is the y-axis, this would be the x-axis. So this would be -1, -2, -3, -4, -5 kilometers here, and then this will be plus 0.15 kilometers in this direction here. Now the function here, f of x, approximately describes the path of the plane's descent. So f of x equal to 0.0024 x cubed plus 0.018 x squared plus cx plus d, and we're taking x here as ranging from -5 up to 0. So we can see here we're starting at -5 and we're going to 0 here. Both x and f of x are measured in kilometers. So they gave us 150 meters here, but that's been changed to kilometers here. First thing we've got to do, in fact the first two parts of this question involve finding c and finding d, and we're told here to show that d is 0. So in order to do that, what we're going to do is use one of the points on the curve here. So this is our function here. We know this point here is -5.15, but if we put that into our equation, it's not really going to work for us. The best thing to do is to use zeros whenever you can, and we have a point here on the curve, and the point is 0, 0. So that's always a handy one to use in these situations. So let's do that. Our function here is f of x is equal to 0.0024 x cubed plus 0.018 x squared plus cx plus d. Now at 0, 0 then, we can say then that y will be 0, and we put the x in as well, so it's 2, 4x. Our x here is going to be 0, we got to cube that, plus 0.018, our x is 0, we've got to square it there, then we've got c times 0 plus d. Well, what you can see here is that we'll have 0 on the left hand side, but all this will be 0, all this will just be 0, and c times 0 is also 0. So we just end up with d is equal to 0. So that's the first part of the question. So we know that there'll be nothing here. Well, 0 will be here, but we can leave this out of the function. Now in the second part, we've got to find what c is using the other point on the curve that we know. The other point that we know is -5.15. So we're going to do the same thing again. So we're going to take our function f of x is equal to 0.0024 x cubed plus 0.018 x squared plus cx, and we know that we don't have to put in d, anything for d here. So now we're looking at the point -5 for x and 0.15 for y. What happens here? Well, we can put 0.15 is equal to, this is our y, and we've got 0.0024 here, and our x now is going to be -5, which we've got to cube. We've got 0.018 here, we've got our x here now, which is -5, which we've got to square, and then we've got plus c times our -5 as well. Okay, so when we work this out, then we got 0.15 is equal to, now let's see, when you work out this bit here, you'll get minus anyway, because you've got minus cubed here times plus, so that's going to be minus, and then all of this then, -5 cubed is 125. 125 times 0.0024 is actually 0.3. When you do this bit here, well, we've got a minus squared, so that's going to be positive times positive is positive. And then 5 squared is 25. 25 times 0.018 is 0.45. And here we're left with minus 5c here. Okay, so we're almost there. Let's see, 0.15 is equal to, when we just add these two, minus 0.3 plus 0.45, we get 0.15. Minus 5c here as well. Subtract 0.15 from both sides and you get 0 is equal to minus 5c. Okay, and then just finally divide across by minus 5. So 0 divided by minus 5 is 0, and here we're left with c. So now we know that c is also 0 in our function. So all of this is going to disappear as well. So our function will reduce down to, I'll write it down here, f of x is equal to 0.0024 x cubed plus 0.018 x squared. The c and the d were both zeros, so this bit here, the bit that would have been out here, is gone at this stage. In this part of the question we were asked to find the derivative of f of x. So let's do that. So the derivative then is, take the power of x here, multiply it by 0.0024. So what you get there is 0.0072. So we've got 0.0072. We've got the x here, reduce the power by 1, so that brings it down to 2. Do the same here, take the 2, multiply it by 0.018, and that gives you 0.036, reduce the power by 1. So that's it for the first part of this part of the question. And then it says, find the derivative when x is equal to minus 4. So at x is equal to minus 4, so when the plane is 4 kilometers from the origin, if you like, f dash x here, the derivative is going to be 0.0072. We've got minus 4 here squared plus 0.036 here, and then we've got our minus 4 multiplied by that. So when we do that, then we get, let's see, here we get 0.1152. 0.1152. So square the minus 4 first, then multiply it by 0.0072. Here we're going to get minus, because we've got plus times minus, and 4 times 0.036 is 0.144. Okay, when we add these two, or subtract them in this case, minus 0.0288. Now what have we actually done here? They're leading us into the next question. We had our original function, we found the derivative of it. When you find the derivative of a function, you're getting an expression here, or a formula if you like, for the slope for the slope of any tangent at any point x. So at x is equal to minus 4, the slope of the tangent will be minus 0.0288. So in other words, if we go back to our curve again, if we take this is our minus 4 here, so when the plane is here, it's pointing down towards, it's pointing down in that direction. So this is my tangent. Not a very good one, but you get the idea. It should be a straight line. This is the direction that the plane should be pointing in, down in this direction here. So the slope there, the slope of the plane then will be minus 0.0288. You can see it is a negative slope anyway, because it's pointing in this direction. Pointing in this direction. If it was pointing in this direction here, it would have a positive slope, and it has a very small slope. You can see that it would be a very small angle of descent here. Okay, so let's have a look at the next part of the question, and it says use your answer to part B1. Find the angle at which the plane is descending. So we've got to find the angle of descent. In other words, the plane is coming down like this, let's say, in that direction. We've got to find this angle here. So this is the horizontal. We've got to find out what this angle here is. Now if you look at this here, really what you can do here is you've got a a right angle triangle here. We know that the slope here is minus 0.0288. This is our slope. How would you normally find the slope? Well, it's rise over run, so it would be this side here over this side here. We take this as our right angle triangle. So this over here is actually, this is the opposite to my angle. This is the adjacent. This is the opposite here, if you like. This is the adjacent. So that's really just the tan of the angle. So you know, slope can be found in a number of different ways. So you can use the derivative, you can use rise over run, which is just the tan, which is what I'm going to do now. So in other words, the tan of this angle, we'll call it alpha here, is minus 0.0288. So if we just get the tan inverse then of minus 0.0288, what we do is, if you type that into your calculator, you get an angle here of, I have it written down here somewhere, where do I have that now? You get an angle of minus, sorry now about this delay, 1.6497. Okay, so the reason I give a negative angle here, this is degrees here, you can see it is quite a small angle. It would be quite a small angle if you take your x and y axis here. If we measure angles in this direction here, they would be positive, but our plane is going in this direction here. So we're talking about this angle here, so we're talking about a negative angle. We're looking at measuring the angle this way. So when we talk about an angle of descent then, which is really what we're asked to do, so we can say the angle of descent is equal to, now we've got to do this to the nearest degree, so this is really 2. If I was to round this to the nearest whole number, it would be 2. So we're talking about 2 degrees. The angle of descent is 2 degrees. Or if you're asked for the direction the plane is going, it would be 2 degrees south of east. Or you could say it's going east 2 degrees south. So there are a number of different ways of saying it, but this is what they're asking us for here in this particular case. The angle of descent is just simply 2 degrees. So that's this angle here. Okay, so let's have a look at the next part. Part C then. Show that minus 2, 0.075 is the point of inflection. So what's that? Okay, so we have a look at our original curve here again. We have the curve goes from here down to here, to around here. It's actually concave downwards. The concave part of the curve is, if I just put it in here, it's this way, it's concave down. Then it changes direction here so that you have a concave part of the curve here that's actually pointing up. So if I was to exaggerate that, for example, the curve would look like, if I was to really exaggerate it, something like this. This is where the concave part of the curve is pointing down, and this is where the concave part of the curve is pointing up. The point of deflection is where that change occurs. So it's somewhere maybe around here. That would be our point of inflection. So how do we actually calculate that? Well, let's have a look. What you need to do here is find the second derivative and let that second derivative equal to 0. So let's take our first derivative anyway. Our first derivative again was 0.0072x squared plus 0.036x. That was our first derivative. So we want to find our second derivative then. So we derive it again. We do second derivative. So multiply 0.0072 by 2, and that gives us 0.0144. We have the x here as well. We've got to reduce the power by 1, so there's just 1 here. Take our 1 here, there's a 1 up here, multiply that by 0.036, you get 0.036. There is an x here, but it's to the power of 0 now, and that will just give me 1. So this is my second derivative, so we got to let this equal to 0. 0.144x plus 0.036, let that equal to 0, and work out what x would be. That would be 0.0144x is equal to minus 0.036. So I just brought that over here, or subtracted 0.036 from both sides. Divide then by 0.0144 on both sides, and you get minus 2.5, which is exactly what they say we should have gotten. So we got the correct x value anyway. To find the y value then, this is the x value on the curve. This is on the curve. So we got to put that into our original function. And our original function was, remember, f of x is equal to 0.0024x cubed plus 0.018x squared. We've got to put this minus 0.25 in here, and hopefully we will get plus 0.075. So let's see what we get when we get that, or when we do that rather. So f, we want to put in minus 2.5. So we get 0.0024 minus 2.5 here. We've got to cube that, and then we've got 0.018 here. We put in the minus 2.5 here, and we square it. So when you do this bit here, you get minus 0.0375. So you square this, you cube this first, and then multiply your answer by 0.0024. So we're squaring this, which is going to be positive, and multiply by positive is positive here, and then that becomes 0.1125. So square this first, and then multiply your answer by 0.018. When you do that, you do in fact get plus 0.075. So that's what they said our point of inflection, is equal to, our x was minus 2.5 and the y was 0.075, and that's what they said it should have been. So that was fine. Okay, next part then, part D. This is quite a long question. So part D now, we just got two parts left to do. So the first part is xy is a point on the curve, y is equal to f of x. Verify that this point here is also a point on y. So we have our original function here. Original function was f of x is equal to 0.0024x cubed plus 0.018x squared. And we're told that we have to verify that this point is actually on this curve here. So let's do it. So in other words, if we put x, our x value in here, minus x minus 5 is the x value, minus y plus 0.15 is what we should get when we put this particular value into this function here. So let's do that. So we're going to do f of minus x minus 5. They're telling you that this is what the x value is, and you should get this particular value out then. So let's do it. 0.0024, we've got to put minus x minus 5 in and cube it. Then we got 0.018 here, and we got to put minus x minus 5 in and square it. So this is quite just kind of a big tedious kind of a question. You got to multiply this by itself 3 times. So let me just come over here. We will end up with 0.0024. Now I'll just do x minus 5 first, and we're just going to square this first, and then I'll multiply it by minus x minus 5 then finally to cube it. So what you get when you square this, if you take minus x minus 5, multiply it by minus x minus 5, you get x squared plus 10x plus 25. And over here then we get 0.018. Now I've already squared this here, so I'll just write it in again. It's x squared plus 10x plus 25. Okay, now what we've got to do is take the 0.0024. Now I'm going to multiply all this out. So multiply the quadratic here by this linear part here. And what you get when you multiply all that out is minus x cubed, that's minus x times x squared, minus x times plus 10x is minus 10x squared. You get minus 25x. Now I'm going to multiply by the minus 5 across here, so you get minus 5x squared. you get minus 50x, and then finally the minus 5 by the plus 25 is minus 125. Now you got to multiply this out, so you get minus 0.018 x squared plus, I should say, 0.018 times 10. So that's really just going to be, if I multiply 0.018 by plus 10x, I'll get 0.18x. Then finally plus 0.018 times 25 is plus 0.45. Okay, so you can see this is just kind of long and tedious. So I got to multiply this out as well. So you get minus 0.0024 x cubed. I got to multiply this by minus 10x squared, so that's going to be minus sorry, no, what I'm going to do here actually is what I'm going to do is I've got a minus 10x squared here, I've got a minus 5x squared here, so that's minus 15x squared. So really what I'm doing here is just taking this one and this one here and putting them together to give me minus 15x squared. I'm going to multiply that minus 15x squared by 0.0024, and that will give me minus 0.036x squared. Now also here, if you notice the x's here, there's an x here and there's an x here, so I'm going to put these two together. I'm going to multiply those two by 0.0024. That will give me minus 25x minus 50x, that's minus 75x. Multiply that by 0.0024 and you get minus 0.18x. And then finally here we got minus 125. Then we've got all of this over here, 0.018x squared plus 0.18x plus 0.45. Okay, almost there. Now we have an x cubed here, there are no other x cubes, so I'm just going to write that down. That's minus 0.0024 x cubed. I've got an x squared here and I've got an x squared here. Put those two together and you get minus 0.018 x squared. Now I have a minus 0.18x here and I have a plus 0.18x here, so that they will just disappear. I get 0 if I put those two together. And then finally I have minus the 1.125 here, multiply, oh yeah, actually what I should have done here, I'm going to go back a little bit here now. This here, I forgot to multiply that by the 0.0024, so when I do that I get minus 0.3 here, 0.3. So this 125 multiplied by the 0.0024 is minus 0.3. So I got a minus 0.3 here, I got a plus 0.0545 here. That will give me plus 0.15. Okay, so finally, after a little bit of messing around there, we ended up with this here. Now, what were we asked to do? Okay, we were asked to put in minus x minus 5 into the function, and we were supposed to get this here out. Now I didn't get that, or at least it doesn't look like it, but if you look at this here, it can be broken down into two parts. You can look at this part here of my answer, and you can then look at this part here. Now this part here is part of the y. I've got a plus 0.015 and I have a plus 0.01 or 0.15 here. Now the other part is minus y. Now remember, this here is just y. This is y here. This is y. This is y here. This was my original function. What is it? 0.0024 x cubed plus 0.018 x squared. But look at this here. This is minus 0.0024 x cubed minus 0.018 x squared. This is just the minus version of this bit up here. So this, if I multiply across here by minus 1, I would get minus y is equal to minus 0.0024x cubed minus 0.018x squared. So this here is simply just minus y. So I can just rewrite this part here as minus y, which is this part here, plus 0.15. So we did actually get this part here. We did get this here when we put this into our function. We got minus y plus 0.15. Okay, there's a lot of tedious maths in here, and it's very easy to make a mistake there. As I say, I made a little mistake here, but saw it eventually. But you just got to be a little bit careful doing this. Okay, so last part, hopefully. Yes, this is the last part. Find the image of this point here under symmetry in the point of inflection. So we have a point here, and the point is minus x minus 5, and then we have minus y plus 0.15. This is the point. We want to reflect that in the point of inflection, and our point of inflection was minus 2.5, 0.075. And we want to see what would happen, what we would get if we reflected this point in this point here. So if you imagine the points, I mean, you're going to have one point here, you're going to have another point here, and your image point is going to be here. The distance along here is going to be the same. This is going to be the midpoint of these 2 points here. So if you take this as A, for example, and this is C, our point of inflection, if you like, B, if we call it B here, is going to be the midpoint of these 2 points. And you can use the midpoint formula to work this out, but I'm just going to do it by using translations. In other words, I'm going to translate this point up to here, and then use the same translation to translate this point to here, because we're looking at the same distance. So we're going to go along to here and then to here. So what do I have to do to this x value, in other words, to get this x value here? Well, I have a minus x minus 5 going to minus 2.5. So what I've got to do here really is I've got to get rid of this x. How do I get rid of a minus x? Well, I add x. Okay, so if I added x to this, I would have no x here, and that's exactly what I want. How do I go from minus 5 to minus 2.5? Well, I've got to add 2.5. So in other words, if I take minus x minus 5 and I did x plus 2.5, just added these two, well, I would get 0x here, and here I would get minus 2.5, and that's exactly what I want. So if I continue that on now, if I do the same to this here, because remember we're looking at the same distance in this direction here, so I'm going to take x plus 2.5 here. So if I take my x here, minus 2.5, add an x, what will I get here? Well, I'll get an x. If I take minus 2.5 and add 2.5, I'll get 0. So my answer here would just be x. So in other words, x plus 2.5, in other words, if I just, I'm not kind of running out of room here, but if I do the same kind of thing here again, if I take my minus 2.5 and I added x plus 2.5, if I added these two, well, here I'll just get x, and here I will get 0. So I'll just get x here. Okay, now let's just get rid of that again. I'll probably use it again. So now let's have a look at the y value then. So we're going from this y value to this y value, and then we're going to use the same translation to get this y value here. Okay, so there's no y here, so I've got to get rid of this y here. So I'll do this in a slightly different color. What will I have to do to this y to get rid of it? Well, it's a minus y, so I'll have to add a y. So I'm going to add a y here. How do I go from 0.15 plus 0.15 to plus 0.075? Well, I would have to subtract a 0.075. So in other words, what am I doing here? I started with minus y plus 0.15. I'm now going to add this to it, so I'm going to add y minus 0.075 to it. Well, that'll disappear, and here I'll end up with 0.075, which is exactly what I wanted. Okay, so now do the same here. Add the same y minus 0.075 here. Okay, so let's do that then. Let's get rid of this again. Now let's take this y value here and add this to it. So we have our 0.075, and we want to add y minus 0.075 to it. Well, y plus this thing up here is just y. There are no y's up here, so just leave it as y. We have plus 0.075 minus 0.075, so we just end up with a y here. So our answer here is just simply xy. When we find the image of minus x minus 5, minus y plus 0.15 under symmetry in this point of reflection here, our answer is just simply xy. Okay, so that's it for this particular question.